Hi, I'm Becky Jaramillo, and we're back here with a couple of engineers that are involved in this IRVE-3 launch, and I'm going to let them tell you all about why they're here and what their roles are. So, Robert, you want to start?
Sure. I'm Robert Dillman. I'm the Langley Chief Engineer for the IRVE-3 mission. Means I'm generally in charge of all of the engineering approach and hardware, and I provide guidance to the other engineers on the job, trying to make sure everything works together and resolving problems as they come up in these last few days before launch.
Okay, so problems. What kind of problems might come up in these last few days that you've had to deal with?
There are generally have been problems mainly with clearances, that we don't have all of the documentation quite closed out, so we get to run around and close that out at the last minute. The hardware's working fine, but there are still some small issues, and we're trying to resolve those issues to everyone's satisfaction so that everyone was comfortable with the launch.
And so that's one of the reasons why you're here a little bit in advance of the launch, to make sure that you can get all of that smoothed out. Neil was here just a little while ago and told us that yesterday is the first time that all of the pieces have actually been put together. So you have to make sure that those pieces all talk to each other and understand and work together. So
a large portion of the payload has already been assembled and together and apart several times, but this is the first time it's been all together on the actual rocket that's going to be launching us. So we need to check all that out, make sure it's still happy.
How many people will be up here with you working on this when you're talking about making sure the other engineers know? I'm sure some of them are not here, but back at Langley.
Right.
So
up here for the launch, we'll have about 20 engineers. There's probably another 30 or 40 who've been working with us regularly back at Langley. Some of them will come up to watch the launch on their own, even if they're not directly supporting the launch, just because we're all pretty well invested in this and want to see it go.
Right, right. Yeah, me too. This is my first launch from Wallops, so I'm kind of excited to be here and get to watch this too. So tell us a little bit about your career. What brought you to be the lead systems engineer here?
Okay, I grew up as a Navy brat. Moved around a fair bit, but junior high and high school were in Virginia Beach, so it's nice to work in Hampton, Virginia. I sort of know the area. And I always thought space hardware was a neat area, neat to work on. Enjoyed science fiction growing up, so became an aerospace engineer in college and got lucky enough to be hired at NASA, where I've worked for the past 22 years now. Worked on the shuttle program and some of the Mars missions, and having a variety of experience on that, able to apply it to the current mission.
So you really have gotten to do your dream job, huh?
I got really lucky.
Who is here with us as well? John? What are you doing here? He's the systems guy. So what are you taking care of?
Yeah. So my name is John Dinonno, and I'm the reentry vehicle lead engineer. And so I report to Robert and try to help the subsystems all come together on the reentry vehicle itself. We have subsystem leads on the vehicle, and the vehicle consists of various subsystems, starting with the aeroshell, and then the inflation system, the center of gravity offset mechanism, the telemetry module, and the NIAC system. All those systems have to work together in order for the vehicle to perform its mission.
That seems like a lot of complicated parts all coming together. So how do you make sure that they are going to work together, or that they do?
It's a lot of collaboration and a lot of solving problems.
So it really is teamwork that makes this all happen. So what's your background?
I'm a mechanical engineer, and I grew up in the area near Langley. I grew up in Chesapeake, Virginia. Okay. And I was always interested in the challenges involved with engineering, and especially aerospace engineering. I worked in the private industry for the beginning of my career and found an opportunity at NASA, and here I am.
So in the next few hours, as we're getting ready for launch and building up to that, what will you be doing?
I will be basically monitoring the subsystems. We have subsystem leads who are also looking at their systems, and I'm making sure that they're happy and that we know that everything's working the way it's supposed to. So we're looking at a lot of different sensors on the vehicle that are keeping us informed that it's working properly.
So are you more nervous or excited?
More excited. I bet it'll change to nervous as it gets closer, but right now just more excited.
Countdown hasn't quite started yet. So when countdown starts, where will you be physically?
I will be in this room in a table nearby at the front with my inflation system lead, R.J. Bodkin, and the electrical system lead, Jeff Massey, and the center gravity offset lead. And that's
So if I
Nathaniel Miller.
understand this right, and yeah, you jump right in here and correct me if I'm not right. As this leaves the rocket, it will be tiny, and then it has to inflate.
Right.
So how do you get it to inflate?
So we have an inflation system of it's a tank, a spherical tank inside the center body that is pressurized to 3,000 psi. It's nitrogen gas. And we have a control valve in that system that monitors the pressures on the air shell itself and inflates it to a prescribed pressure.
Okay. So, Robert, where will you be?
I'll be right here in the control room as well. There'll be a line of engineers across the front supporting the project manager. We'll be in the back row with a lot of the Wallops personnel. And when it comes time to launch, we'll go through our checkouts, make sure the hardware is functioning properly, tell the project manager that we're all good. He'll tell Wallops it's a go.
Okay. So several people will have to sign off, just like they'd have to sign off on a big launch for a much larger rocket.
Right.
All those same pieces have to be in place, and then your jobs kick in as you're watching all of this unfold in front of you.
Yep, we're looking forward to it.
Good, good. Well, we're really excited to be with you here today. What advice would you give to kids that are watching current science fiction, reading some story out there, thinking about space? I mean, we've just mentioned that today is July 20th, an anniversary for NASA, anniversary of the moon landing. Tomorrow, July 21st, another big anniversary. It was 1 year ago tomorrow that Atlantis touched down for the last time, and we stopped flying the shuttles. So what's in the future, and what advice would you have to give those kids out there?
I guess the advice would center around finding something they really enjoy doing it, because hopefully they'll be doing a lot of work throughout their career. So they ought to, if they enjoy or find space hardware interesting, study hard in their math and science courses and go out there and get a job working in the area they're interested in.
Okay.
Hopefully they'll have a long, enjoyable career at it.
And they may be flying the next generation of IRVE-3 or something that's going to take us someplace really exciting.
And we'll need more people in order to do that.
All right. John, anything else?
As far as advice?
Yeah.
I would say don't worry if you don't have everything defined that on the path you're going to go. Be open-minded and try to rise to challenges, because I could never have told you I'd be working on an inflatable heat shield 10 years ago.
Wow, really? Well, thank you both very much for joining us. We appreciate having you come over here and meet with us. We're going to take a short break, and after that, we'll be back with R.J. Bodkin and Nathaniel Miller to tell us more about some of the subsystems on IRVE-3. So we'll be right back.